This tutorial will show you some of the features of the equivalent frame tool found in SAFE. Equivalent frames approximate 3D slab systems with a simplified series of planar frames. The equivalent frame may be defined directly by the user or generated from an existing SAFE design strip. The frame may be supported by columns, walls, or soil. It may be post-tensioned, and both beams and slabs may be modeled. Models that have only column strips, that is, strips that are an entire bay wide, are best suited for the equivalent frame method. Note that the width of the design strip along grid 3 is 24 feet. We start the model by clicking on the Tool's Equivalent Frame command. On the Equivalent Frame Models form, we may either start from scratch or from a strip object. For this time, we choose the strip option and then column strip A along grid line 3. Note that the equivalent frame has 3 spans. Each span is 24 feet long, as was the case with the original SAFE model. Next, we will go to the View menu and review the items to display. For this example, we will keep all items visible. Next, we go to the Define menu, where we can review the materials and object properties. These items are the same as used in the primary SAFE model, and any changes made here will affect the SAFE model in addition to the equivalent frame model. The equivalent frame form is divided into 2 primary areas, the display area and the data table area. The Edit menu contains the bulk of the commands needed to create and modify the equivalent frame. The data table displayed is based on the command selected. With span data selected, the span lengths may be altered or additional spans added. The grids are located based on relative distances and do not remain locked to the columns. We will show how to adjust these later. We can also adjust the vertical scale to make our model look more slab-like. Switching to the slab data, we can see that the width of the slab is 12 feet on each side, or 24 feet total. Post-tensioning can be added by clicking on the Tendon Data command and then the Add button. Tendon vertical profiles loads and losses may be set in the same fashion as for the main SAFE program. However, for this model, we will not have any tendons. Next, we will review the loads. You may place point, line, or area loads on an equivalent frame. The area loads brought over from the SAFE model are 20 pounds per square foot for the dead pattern and 80 pounds per square foot for the live. We can display these on the model by selecting the pattern here. Placing the cursor on the model displays the load values. We will add a line load to the area live load. In this case, a load that varies from 0 to 1 kip per foot. Any load may be removed by selecting it and clicking the Delete button. With the spans, slab, and loads reviewed, we will next check on the supports, in this case, point supports, which represent the columns. In the data table, we see that there are no columns above, only columns below. We are now about ready to run the analysis, but before we do, we will take a look at the display menu. Note that the only command active prior to running the model is the Show Undeformed Shape command. We will now run the equivalent frame analysis. The display is then updated to show the deformed shape, and if we place the cursor on the frame, we can see the value at that location. The maximum and minimum values are shown at the bottom of the display, and the tabular values are displayed as well. Going back to the display menu, we can view forces, such as moments, or axial stresses, or the computed reinforcing. Next, we will create an equivalent frame model from scratch. We will not use the design strips. The first step is to define the span data. We will have 2 spans in this model. Next, we move on to the slab data. The slab will be 8 feet wide on the left and 10 feet wide on the right. At this point, we could use the beam data command to add a beam. But for our model, we will use the slab only. Next, we will add supports. Select the middle support and click on the Support Details button. On the point support form, we can specify the support above and the support below. If a drop panel is to be included in the equivalent frame, it should be specified on this form. For this model, we will remove the bottom column support. To help support the slab, we will add a longitudinal wall under the first span. The presence of a wall is indicated with a gray line. Under the second span, we will add soil support. Next, we will add some loads, starting with a point load. We will add a 5-kip dead load at mid-span of the first span. We will also add a line load. That varies from 2 to 4 kips per foot for the live load pattern. The last load type is area loads, but for this model, we will skip this load type and move on to grid line data. This option allows us to add grid bubbles anywhere along our frame. Now we will run the analysis and design. Again, we can review the forces and design reinforcing. Clicking on the OK button returns us to the equivalent frame models form, where the model just created is shown on the list. The equivalent frame model is saved with the primary safe model, so at a later time we may return to it for review or modification. This concludes this tutorial.